Hello, 8th graders. We are going to start Unit 8. We're going to do the first two lessons here. And Unit 8 is all about irrational numbers and the Pythagorean theorem, which sounds a lot more complicated than it is. But we're going to start out this unit by looking at areas of squares. So something that we are a little bit familiar with. So here we go. Okay, a quick reminder is that to find area, we take the length times the width. If we start with rectangle A, it's going to have a width of 2 and a length of 4. So 2 times 4 would be 8. So the area of the whole thing is 8, but I just want the area of the shaded region. So I'm going to break it into pieces. I'm going to look at this part right here and this part right here. And I noticed that if I actually put those pieces together, I would end up with something like this, which would have an area of 2. And I noticed that over here, I could do the same thing with these two pieces, which would also have an area of 2. So I'm going to say that these two pieces put together has an area of 2, and these two pieces put together has an area of 2. So if the whole rectangle A has an area of 8, and I'm going to subtract off all those corner pieces, which would have a total area of 4. That means that my blue shaded part has an area of 4. Here's what square B would look like if we did a similar process. These two triangles put together would have an area of 2, same thing over here. And so my total area would be 9, because that's my 3 times 3, minus 4, that's coming from those two put together, would be 5. And so square B is going to have the larger area. Okay, finding the area of this square, again, we're going to be decomposing, meaning breaking it into pieces, which is what we just did. So my bigger outer square has dimensions of 10 by 10, and now I'm looking at these triangle pieces that I want to eliminate. When the square is tilted like that, we can't just count the side lengths very easily. So these two triangles, I notice have a length of 9, and so if I put these two together, they would have an area of 9. Again, you have to visualize. If I put them together, it would look like this, with one triangle here, the other one over here, and in all it would have an area of 9. And the same thing over here. These two are going to have a total area of 9 right here. So my outer square has an area of 100, that's 10 by 10. I'm going to subtract off 18 because of these two areas of 9, and that's going to give me 82 for my area of the square. Okay, so this one is missing some of the grid lines, but it's the same idea. My big outer square is 10 by 10, and I'm going to focus on these pieces that I need to subtract off. They have dimensions of 5 by 5. And so if I took 2 of these triangles and put them together over here, they would make a square with dimensions of 5 by 5, which would have an area of 25. So those two make 25. These two on the other side will also make 25. And so my area of my total square was 100, 10 by 10. Subtracting off 50 for all those places in the corners, which would leave me with an area of 50 square units. Start getting used to putting that label of square units on your work. Very similar thing here, even though we don't have grid lines anymore, they gave us some measurements. So my big outer square is 10 by 10, and the tilted square in the middle we're going to find by subtracting. I can see that if I put 2 of these triangles together, I would get a rectangle with area of 21. And so I'm going to subtract off that total of 42, 21 plus 21, which would give me an area of 58 square units. Okay, there's your answers for squares A and C. When you get to the area of square B, you can do what we just did. You can add that square that goes around it, because again, we can't just count the side lengths of that tilted square. So this is what square B would look like using the same process we just did. And to find the area of square B, I would take 49, that's my 7 by 7 outside square, minus 24, because that's the total of all those corners. And I would get a total area of 25 square units. And then lastly, what is the side length of square B? Well, if its area is 25, then its side length, or like this side right here, needs to be 5 units long, because 5 times 5 equals 25. Okay, to talk about the square F here, it has dimensions 8 by 8, so the total area of the outer square is 64. I'm going to subtract off all of these triangles, which total area for those would be 30, and I end up with an area of 34 square units. We are going to skip the last activity in this lesson, so let's keep going. Okay, in lesson 2, we're going to look at more squares and side lengths. Okay, notice here that we are on activity 2. We did skip the first activity in this lesson. Okay, the point of the circle here is that if I did rotate my square and brought it down to be right there, lined up with my axes, you'll notice that the side length we can find by looking at the coordinate on our x-axis. And so let's approximate that to be 5.3 for my side length. And so from here you can find the area of the square. Okay, from our estimation of a side length of 5.3, we would find the area to be 28.09. Again, that's an estimation. Now that you have a grid, you might be able to estimate the side length a little bit better, or we could actually draw the big square and find the area that way. So if we draw the big square, we're actually doing it a little more accurately. The big square has an area of 49, 7 by 7, and I'm going to subtract off 20 because that is the area of all these triangles, and I would get an area of 29 for my tilted square. Okay, to start this one out, you are finding the area of tilted squares A, B, and C. My suggestion is to create those big squares around like we did before, and then find those areas. Okay, so here's how all 3 squares would end up once you found those areas. And let's just look at square A first. It would have an area of 29 square units, and it's also asking us to find the side length. Now earlier when we had a square that had an area of 25, we knew the side length was 5 because 5 times 5 equals 25. But we don't have a nice number like that for 29. But instead we're going to say that the side length is the square root of 29. Because in math, if we took the square root of 29 times the square root of 29, we would get 29. And so that square root of 29 needs to be the side length. The same thing is going to happen in square B. The side length is going to be the square root of 18 units. And in square C, the side length is going to be the square root of 13 units long. Okay, as we move on to number 2, completing this table, one thing to remember is that to find area of a rectangle, we found length times width. When that's a square, the length and the width are the same, so then we just call that the side length. And we can shorten this by saying that the area is going to equal the side length squared. So if you go to your table, if I know the side length is 0.25, I would square that, or take it times itself, and I would get an area of 0.25. Feel free to use a calculator on this. If I know the area is 1, I know the side length has to be 1 because 1 times 1 equals 1. I could keep going. If the side length is 1.5, 1.5 times 1.5 is going to be 2.25. And if my area is 4, I know the side length has to be 2 because 2 times 2 equals 4. Go on and finish your table and start again when you're ready. Okay, there's the finished table there. One thing I want to point out is that these really nice numbers that we have, we also call those perfect squares. And I did post a reference on Canvas for you for those perfect squares that might be helpful as you continue your work here. We are going to skip the rest of this lesson. We're going to stop here and go ahead and start your practice problems.